we're the hydroponics team, and we're gonna show what the improvements and the changes that we made to the hydroponics tower. So the main objective of the main requirement of the client was the drainage. The initial hydroponic tower did not have any drainage outlet, so all the debris and water, the bad water, was resting here and it was clogging the pipes, and because of that the quality of water was going down and the plants were not able to grow. So for that we made a new piping system. So for the pump we did a T-joint for the pipe right there. That's for the inflow, and we added a tap so that it goes whenever we want. And for the outflow we also added another tap using U-joints for the pipes, and whenever we open this it goes in the drain. So I'm gonna show how the drainage works, and I'll close the on this one. Right. And I'll close this thing, so it's gonna drain all the water here. And if I close this and if I open that, it's gonna start the hydroponic pumping system again. So initially there was a problem with the clogging here because it was a big bend here, so the pipe used to bend and there was a big problem there. So what we did was we used these joints for the pipes, and we added another joint inside, which I'm not able to show right now, so that at least the pipe remains 90 degrees straight and the water doesn't block, so it keeps on running smoothly. So I'm gonna show the drainage and how it's gonna happen, so that she knows how it's like a manual right now, because she just needs an extra bucket which the bad water will go in. So all she needs to do is turn this tap around 90 degrees and turn this tap around 90 degrees more, and it will start flowing the water. All the bad water goes in, and we want to show you when it reaches here, we put the pump in a position which uses the maximum capacity of the pump. So instead of putting the pump in a different, like I'm not able to show it, like instead of putting the pump like this, we're putting the pump like this, so that because of the water flowing here, it's able to use the functionality of this pump to the maximum. So only like 1 millimeter or 2 millimeter of water will remain, the debris, the bad water, but that can be clogged or used like we can get it out using like towels and stuff. But that would not take, if there's regular cleaning of the system for like every month, once a month or twice a month, that would not happen. But like as you can see, the drainage water is almost filling here and it's very quick. She doesn't have to take this bucket out and drain the bad water, which she was doing before, and the bad water was just sitting there. Okay, so we're at the bottom part of the water, and as you can see, it's suctioning in because the pump is like that. It will suction all the water, and if you can see, there's not a lot of water here, and even that will drain out in a short while, and only this amount of water will remain. And if you keep cleaning it from every once a month or twice a month, this won't affect the cleanliness of the whole system, and it won't clog the whole pumping system as well. So the second requirement from the client was the plant growth is nice. So for that we use these kind of buckets, which we use for holding the plant. So I'll show it. So it goes like this and it holds the plant so the debris doesn't fall inside. So because before the debris was falling inside and it was clogging, the roots were clogging the water, so it was affecting the pumping system. For these, we use these buckets kind of things, but these are of cheap quality, they don't last longer. So we came up with a new solution which we found in one of the hydroponic stores, which is called the cloning pods. These are able to hold the plant in upright position on the holes, and they last longer, and they last for 2 to 3 years, and they last longer than these. So how does this work is we put the plant inside and you put it here. I'm not using the bucket right now, so they go here and they hold the plant for a regular upright growth. So without the use of these pods, the plant would just rest on this, and the roots would rest on the red plates, and that would clog the pumping system. If you can see the small red holes, if there's roots resting on it, it might block the whole pumping system. So with the using of these pods, what we do is we put the plant inside here, and it just rests perfectly here, and the roots only touch this up till here, so that at least the water touches the roots, and the roots don't go as down as they don't need to rest on the red plate. So because of using of this, what we do is we eliminate the clogging system, and it helps to us to regulate the pumping system. So as one of the requirements from the client, she said that the splitter at the top was not working. It was clogged, and there was not enough water flow, so that the water wasn't even reaching, and it wasn't spreading the water in all these 4 directions as it should. So for that, what we did was, if you can see inside here, the splitter, we rested the splitter on one of the plates. So the splitter rests on the red plate and it spreads the water completely uniformly, and because of that the water flows in all the directions. So it's important, because if the water just flows in 2 directions, only plants on the right side will grow and not on the left side will grow. But if it spreads uniformly, all the plants will grow uniformly, and which is what we want. So the splitter, if just because of splitter resting on the plate, that's an important part, because of that, it's spreading the water evenly to all the holes. So as the third change, what we did was we added a mesh in front of these lights. What was happening was the plants would grow, so something like this up here, the plant would grow up till here, and it would start touching the light and it would burn the leaves. So as a requirement from the client, she wanted us to make that go away. So what we used, our idea was to put a mesh around it, so if the plant grows, it won't touch the light, or when in like full contact, it would just touch the mesh and it won't burn because of that. So one of the requirements, the last requirements from the client was she was not able to grasp the plants. So imagine there's a lot of plants, like if this is in full condition and all the plants are fully grown. So she was not able to reach the top of the plants here. So she was having problems getting the plants here. So what she recommended was 2 things. Either we rotate the whole system to just get the plants from the back, or either we make another door. So we went for another door, because rotating the system would bother the structure integrity of the whole system. So we decided to put another door. So what our plan was, we make another door here, we take this plexiglass out, and we make just like this door, we make another door, and it opens so that she's able to grasp the plants here, and she can just take it out easily from both the sides, and it gives more access to her. It gives more easy like she can do things like whatever plants she wants to take it out, she can grasp those easily. It gives her more freedom, which is what we need for our client, but we weren't able to finish it right now. We have the door we have the door which is completely made. If we had enough time, we would have drilled holes and we would have put the door in, but we'll give the door to the client because we didn't have the time because of the virus. We would have installed the door right now. So this is the panel that was installed before, but it's not working at all. As you can see, it's all dusty, it doesn't work, the screen doesn't open. So one of the last requirements from the client was, if we have the time, we can install a pH meter, a nutrients meter, or if it's combined in one. But we do have that. We didn't order it right now. We were gonna order, and she was gonna make the appeal to the department to get some more budget, which would get us the new pH meter. but if we get it, we would be able to install it right here, and it would go, the meter would know all the values of the water running inside, the nutrients level, the pH and the temperature, so that it's easier for the client to see how much is the pH. If it's going bad, let's change the water. If the temperature is too much, she can put a heater. If the nutrients level is perfect or not. So if we had a pH meter, we would have installed it right there. Whatever the client requirements were, we almost finished those. Just the door, we weren't able to do it. If we get 2 to 3 more hours in the lab, we can easily put the door inside, and just we need the drilling, because the only thing was we have the door, we couldn't install it because we don't have enough time right now because of the virus. So if we get the access in next few weeks, we'll put the door. If not, we'll give her the door and we can do it later on. So I hope that our client is happy with all the changes that we have made to our hydroponic tower. We've almost met all the requirements that were needed. The major requirements, the drainage system is working perfectly fine, and I hope she doesn't have a problem with the debris now. We've used the paws to reduce the residue, the roots build up in the system. We've worked on the lights, we've worked on the mesh. It's just the screen door that is remaining. If we had time, we would have put it there, but because of the new regulations, we're not able to put the new screen door, like put it in the place. We have the new door. It's just gonna be, we need 2 to 3 more hours to put it back. And I hope the hydroponic tower works and it keeps on running for a long time. Thank you.